Unit 4, Geometric Reasoning. Section 1, Angle and Triangle Properties. This is found in Chapter 2 of your textbook. Curriculum Outcomes. At the conclusion of this section, you will be able to develop spatial sense. So, you'll be able to derive proofs that involve properties of angles and triangles, and solve properties that involve properties of angles and triangles. In this section, the rules for geometry from past courses will be reviewed and then applied to new situations. Proofs of why concepts work will be performed. Something called a T-chart will be used. This section focuses exclusively on angles with regard to triangles and parallel lines. Try to remember the 3 different types of triangles as I go through the following. Here's a checklist of requirements to complete this section. Pre-assessment, followed by 5 parts, each one again having notes and practice. So they're exploring parallel lines, angles formed by parallel lines, angle properties in triangles, angle properties in polygons, and proving congruent triangles. Angles and triangles review, there will be a formative assessment, there'll be a curriculum review, and there'll be a quiz. The unit exam, of course, will be when you're finished the actual unit, which is at the end of Chapter 3. So there's only 2 chapters, 2 and 3. Now, this little diagram I've drawn here for you, you might actually be able to do that by the time you are done this course, or this unit, either one. Some things that you may want to have are a ruler and a protractor for measuring angles. Okay, so that's the little half circle Dewey with all the angles on it. Okay, good. Both will be kind of useful down the road. Let's see what's in store. Okay, so part 1, exploring parallel lines. Here's a bunch of definitions for you. I'm not going to go through these with you because I'm going to have you do them by yourself. So I want you to go through and I want you to find these. You'll just need to look in Chapter 2 of your textbook. That's just not what I'm after. Let's try this. One more time. Chapter 2 in your textbook, and you will actually just be able to go through and take a look at the definitions are all there in the bold. So you can check with your teacher when you're finished to see how you did. Okay, moving on. Obviously, you should pause the video and do your definitions before you continue on with this part of the notes. When a transversal intersects 2 parallel lines, how are the angle measures related? Again, if you don't know what transversal means, you probably should stop the video and go back and do your definitions. If you're okay with that, then let's keep going. Develop a conjecture to predict the measures of as many of the angles A to G in this diagram as you can. Okay, so I know that A and 140 are supplementary, meaning they have a sum of 180 degrees because they're on the same straight line. So I'm going to predict that A is 40 degrees. Now the same thing will be true for A and B because they are also on the same straight line, this one. So A and B must add up to 180, therefore B would be 140. Notice that B and 140 are across from each other. Interesting that they're the same. Good. If you take a look at B and C now, they are on the same straight line. So again, they add up to 180. If B is 140, then C must just be 40. 180 take away 140. And again, if you'll notice, A and C are vertically opposite each other, so they seem to be equal. Good. Let's keep going. Now, D and 140, or the D does not look like 140. D looks more like C. So I'm going to guess that D is also 40 degrees. And again, it shares with E, so E is 140. And F also shares with D, so that's 140. Because again, D and F should add up to 180. And then F and G share a line, so G is acute or less than 90. So I'm imagining it's going to be 40. If you have a protractor, you could take out your protractor and measure and just see if A and C and D and G are the same measure, even if they aren't 40, because it might not be drawn to scale. Do the same thing with B and E and F. See if they measure the same. What you'll actually find is that my predictions are correct. So, do your conjectures about angle measures hold when a transversal intersects a pair of parallel lines? Yes. Okay. The rules for straight straight parallel lines hold. Okay. Do your conjectures about angle measures hold when a transversal intersects a pair of non-parallel lines? Use diagrams to justify your decision. Okay, so here are my non-parallel lines. And I'm going to do a little color change here. I like that berry color. And there's my transversal. Okay. Now, if you'll notice, these look roughly like they're 90 degrees. Okay? So, those all have to be 90s because they add up to 180 in all directions. However, if I were to look here, okay, this one is definitely greater than 90, or obtuse, where this one is definitely less than 90. Oops, I got those signs backwards. Often happens. Greater than 90, and this one is less than 90, which means acute. Okay, so I don't believe they hold. The conjecture does not hold for non-parallel lines based on my diagram. Okay, good. Let's take a look at the key ideas from this section. Okay, angle rules. When two parallel lines are cut by a transversal, the following angle rules apply. Alternate interior angles are congruent. Okay, so how do I show parallel? See these arrows here? Okay, those indicate that these are parallel lines. So this line here and this line here. So interior alternates on those parallel lines would be this guy here and this guy here. They're the same size, as well as this guy here is equal to that one there. So that's what we mean by interior alternates. Alternate means on opposite sides of the transversal. Interior means in between the parallel lines. Corresponding angles are congruent. Corresponding has one interior and one exterior. So if this is E, it's interior. The exterior is this angle right here. Okay? So those would be called corresponding. And congruent, of course, the word congruent is just a geometry term that means equal, the same. Okay? And vertically opposite angles are congruent. So if we see here, this one's blue and this one's blue. So vertically opposite means they are opposite each other across a vertex. So this point here is called a vertex. It's a point of intersection. And they are across that vertex. That's why they're called vertically opposite. Okay? And again, they are the same. When a transversal intersects a pair of non-parallel lines, the corresponding angles are not equal. And remember that two angles that lie on a straight line are, what are they called when they add to 180? Supplementary. Oh, that takes you back to some elementary days, doesn't it? Complementary means, remember, that they add to 90. Okay, and supplementary adds to 180. Okay, pretty short little lesson. I want you to take a look at page 72, questions 2 and 5. Show your teacher when you're finished.